Let's look at a more realistic network um, in Packet Tracer. And what I've tried to do here is show you a good approximation of what a real company network uh, would look like. So over here on the left hand side, I've got a couple of networks connected to something I call the internet router. This represents the internet itself. Now I just randomly picked these IP ranges. Uh, I'm sure they're being used by somebody somewhere because we have pretty well allocated the whole uh, IP version 4 namespace or number space. So on the right hand side, this would all be the company network. This would be your responsibility. Now down here at the bottom, I've got what I call the internal company network, and notice I use private IP numbers for this. Now it's got its own interface on the router, which means we can filter there if we need to. We can uh, assign access control lists to this interface. We also have on another interface on the company border router a number of computers, and this is what I would call the service network. Other people refer to this as the demilitarized zone. I don't really like that name because I think there's a lot going on here. Service network, I think, is more appropriate. What I have in this service network is a couple of DNS servers, and you need two if you register your company domain name. You must provide the IP address of two DNS servers that are authoritative for your domain. Um, so there's the two. I put in one mail server. Depending on the size of your company, you may want to have two, as a backup. I actually put in two here. I didn't really need this one. I don't think I do anything with it. Also a web/FTP server. So I'm running two services on that same server. We don't use FTP nearly as much as we used to, which is probably a good thing because it is notoriously, or has been in the past, been notoriously vulnerable to exploitation. So, as a general rule, don't run any services you don't absolutely need, and that particularly goes for FTP. Um, I put it in here because that'll give us something else to configure an ACL to filter, uh, so we'll get more practice configuring access control lists. So um, that's the layout of the service network. Now notice down here on the internal company network, I've got an internal web server. I've got an internal DNS. And these should only be accessible from inside the company network itself. There's, I was going to say there's never a reason you want to make this accessible from the outside. That's not necessarily true. There might be a reason, but for the time being, let's just assume there's not. There's other ways you can give access to these things, probably through like a virtual private network, for example. Um, but you may be wondering why there's another DNS server inside on the internal network. Well, this is the way I like to do it, particularly if you're going to be running, this is going to be a Microsoft Active Directory uh, network. Um, Active Directory requires DNS, and it has to function properly. And I think the best way of doing it is to split your internal DNS from your external. So up here in these publicly accessible DNS servers, the only thing I'm going to have here is uh, the the address records for um, my services. There's nothing private, nothing about the private network is going to be on these guys. and this one you just configure to forward uh, requests for outside uh, name resolutions to your external servers and let them handle it. But anyway, that's a little bit beyond what we're going to do here. Uh, so let's look at some things here. And keep in mind, right now, there is no access control list here on the board router. It's just wide open. So let's, in simulation mode, I want to show you how you can test a few things out, and then we're going to put in access control lists and see if those things still work. So this is a way of testing, what kind of traffic can get through and what kind is being blocked. Now, one thing I did do here, and you should probably do this on yours, I clicked on show all / none, and that just wiped out all the different filter types in the event list here, and then I added in what I thought I would need. So you'll notice here I have ARP, DNS, ICOMP under IP version 4, and technically you wouldn't have to do ARP. I just like to make it as realistic as possible. And then I've got HTTP, the web service. I've got the file transfer protocol enabled, and I've got the simple mail transfer protocol, although I don't have it working correctly yet. I've also got POP3, which is the post office protocol. For my purposes right now, I think this is enough. If you leave all your filters on, you're going to generate a lot of traffic here, and it's things that you don't really need to look at. So we're in simulation mode. We've set our filters. I'm going to go over here. And remember, this computer is on the internet. And if you click on it, left click, and go to the desktop, there's a number of things here that we're going to use to help us see what works right now. I'm going to click on the one here that says web browser. Now, this is a simple web browser, and I'm going to type in www.mycompany.com. Now, before I click go here, I want to show you on this DNS server, under DNS, under services, under DNS. Notice there's a mapping here between the fully qualified domain name www.mycompany.com that associates that with the IP number 202.71.12.14. So there exists a record in this DNS server for the common name, if you will, of my web page server, my web server. And I've got this computer, I've configured its DNS server as this machine. Now, if you were configuring a Microsoft machine, what I'm talking about here is this is the preferred DNS server. So I had to do that to get this particular part to work. So what you see here, I've tried to make as realistic as possible within the confines of what I've been able to get Packet Tracer to do. It has its limitations as well. So if I click on go here, I'm going to start the simulation. So our first packet here, notice, is a DNS type packet, which you would expect, because at this point the PC here doesn't know how to properly address the request for the web page. So what you see here is traffic going to the web server. As soon as I click on this, it starts on its own. Well, let's look at the PDU details here. I'll go inbound, and this particular packet is a UDP type packet, and it's contains a DNS query asking for the IP number associated with www.mycompany.com. Now, let's look up here. Yeah. Under UDP, notice the destination port is 53. So that's what most DNS query type traffic has a destination port of 53. Usually we would go on and turn on TCP port 53 as well. Every once in a while there's a longer TCP type packet that needs to go through that's associated with DNS. Notice the source port here is just randomly generated by the computer that generated this packet. So that's what we're looking at right now. Let's click it on through the switch. Now that was, I'm not sure why it sent it to all those different ones, because it knows where it's at. That should have been an ARP type packet. I noticed that earlier. Every once in a while, I just don't know why we're seeing what we're seeing. So let's look at this type, this particular packet. And we'll see now, still UDP. Notice source port, destination port have reversed, swapped. There's our query, but now we have an answer. So www.mycompany.com is associated with the IP number 202.70.112.14. So this is our DNS answer. And it'll run back, be delivered back to the PC. And at that point, the PC here will have the proper information to correctly address the web page request packet. And you'll see here, let's see if I can stop this. This particular packet, and let me show you what's going on here. Layer 4, it's a TCP type packet. Source port, again, randomly generated. The destination port is port 80. So this packet, if you're going to try to filter this, you'd be looking at TCP port, TCP packets with a destination port of 80. Okay, if you were filtering at that level. So let's run this one through and see what happens. And sometimes it seems like Packet Tracer just sits there for no particular reason. So you'll notice that the packet just cruised right on through the border router. No filtering going on there. Now, one thing I will point out here, let me see if I can stop this for a moment. If this is the company web server, you know, the internet-facing company web server that we expect people to be able to access from the internet, you've got to allow for that and let it through the company router. We haven't configured any access control list entries here yet. But once you put on the first one, you limit everything else. So if you're going to put any sort of ACL in here, you got to make sure that there's a line there that lets traffic come from the internet to your web server. Otherwise, you don't even need a web server. So remember, if you put the first statement here in an ACL, that's the only thing that gets through. So you got to add everything else back in that you need. And we'll soon be back down here. And there's our web page. So, and you can change this if you want to over here on the server if you want to make it look somehow differently. So that worked for web pages. And now let's stop this particular simulation. This whole buffer full message is very much infuriating. I don't know what it's basing that on. It's done that for years. It drives me nuts. It looks like for some reason our web server moved a little bit. So let's put that back. So that was how you could check web traffic. Let's see what else we can do. Let's see if we can check our mail, for example. So I'm going to use this one again, and back on the desktop you'll notice we have an email app. And what's happened, what I've done here is I've configured what you see here is in essence an email client. I've configured it to use 202.71.12.12 as its email server for both incoming and outgoing mail. And I've configured this particular client with a username of Bob, and the password on all these things is capital P, lowercase ass, 123. So let's check our mail. Now again, we're in simulation mode. So when I start clicking here, we're starting off with a POP3. Now, I've noticed this before when it's doing POP3, and I don't know why it skipped the part where it checked DNS. You see, if you noticed a while ago, as part of, well, as part of the DNS zone here, I have configured a mail server. Actually, I do know what happened there. It didn't have to in this case because I gave it the IP address. So it didn't need to go to DNS, did it? Good, I'm glad I figured that out. We could have put it here in the configuration. We could have put in the fully qualified domain name. Then it would have been required to go to DNS. Good. So here's our POP3 request. Hopefully popping along here. Just for curiosity, I want to see what's in this. So inbound. This is a TCP type packet. Destination port 110. You need to know these things. POP3. It doesn't show us the data here, so that's okay. What I'm interested in here is this is TCP 110. So again, if we start configuring ACLs here, we may or may not want traffic on TCP port 110 to be able to go through here. Maybe, maybe not. You'd certainly want it to be able to come from the internal network, but this is a decision you're going to have to make, and it could be that if Bob's always going to be using this computer, you put in a specific entry in the access control list for Bob. So something to think about. And you wouldn't refer to that as Bob. You would say you specify the IP number. So the request goes to the web server, or excuse me, the mail server. So again, packet sails right through the router. Now, I didn't think a while ago we should have basically sent a message, and we could have done that. We could have done compose and send a message. We're Bob. We could have sent one to Bill. But I'll leave that up to you. You can play around with this. By the way, Bill is set up to use this computer right here, I think. So what have we done so far? Again, we filled up our buffer. Did I mention that this hasn't worked right for years? So let's clear that simulation. So what have we tried so far? Well, we've, in the process of accessing the web server, we verified that DNS works. Let's try, see what else we can do. Well, we also checked our mail. Let's try one more thing. I'm not sure why it does that. Let's go back to the desktop and go to the command prompt, and I've been fooling around here. Apparently none of the clear screen commands work, none that I've found. But let's do this. FTP my company. I think I have this in DNS.com. Let's see. So again, we're going to run the simulation, so let's see what happens. DNS type packet. Now while it's doing this, I will point out that I've got this computer configured to use this IP address for its DNS server. That's not exactly how things work in a real network, but within the limitations of my my simulation here, that's the only way I could come up with doing it. So keep that in mind. Hopefully you're in previous classes you had a more thorough explanation of how DNS works. So this is not quite realistic. I'm just curious if we got an answer. I don't know where we're at now. I keep clicking the wrong thing here and messing everything up. Yeah, we're good. It got an answer. I've forgotten if I actually had a mapping in there for that. So now, it went on with a couple more things here. And I think it might have went all the way over, and while I was trying to see what was in that one particular packet. I like some things about Packet Tracer. Some things just drive me crazy. Let's look at this packet briefly. Now remember, this is the one that came back. Notice it's a TCP type packet. It was sent to port 21. That was the packet that went out. So now it comes back from 21. And again, the 1043 was just randomly generated by the operating system on this PC. I was looking for the response. So we got a code 220, and it says, "Welcome to the Packet Tracer FTP server." So, sorry, while I was trying to look at the packet, this is what happened. And I think you can actually back up and see these. We'll try that in a moment. For right now, let's go look at what happened here on the command line here. So to check FTP, I'm doing command line FTP here. There's actually used to we had FTP clients that we could use. But you can also do this on the command line. So again, this PC had to look up the address, the IP address of ftp.mycompany.com, and the connection was made. And this is what we saw in the packet, code 220, welcome to the PT Packet Tracer FTP server. And if you want to go on and log in, it's Cisco, and I'm not sure I remember what you can go and look at this. I was trying to remember what the password was. But you're going to watch the traffic go back and forth here. But the fact that we've got the welcome, the banner is what that's called, back means that, again, since we have no ACL, the FTP traffic sails right on through. And we can go over here and look at password Cisco. And you'll notice when the packet gets back, it's asking us for the password. I think we've seen enough of this. So I'm going to stop this simulation. It's about time for it to tell us if the buffer's full anyway. Oh dear. Let's go back to real time for a moment while I kind of wrap this up. Now, I did this in simulation mode just to show you what was going on. Once we start configuring access control list here, I want you to test out that your ACL is working. You don't have to run it in simulation mode. Matter of fact, I wouldn't unless I was having some kind of problem. Let me see if I can just get out of this and show you what I was talking about. Notice that when I'm in real-time mode, I don't have to wait for the packets to move around. So for testing purposes, I just run real-time. But unless I had trouble with something, if something didn't work like I thought, go to simulation, see where things are really going. Just keep in mind that sometimes Packet Tracer doesn't do exactly what it should do, but it's pretty good, really. So that's all you'd have to do to test FTP. So what I'm going to do is I'm going to post this online in Blackboard, and you can download this, and I'm going to give you some rules that I want you to implement, and there'll be I'll have another probably, I've got an older video that should show you what you need to know about how to configure an ACL. If I get the chance, I might redo it, but I'm not sure I'm going to have time. So I'll give you some things I want you to, basically we're going to look at this as traffic flows. For example, from the internet, all DNS needs to be able to go to these two machines, and that'll be UDP port 53. And then from the internet, all TCP traffic to port 80 needs to go to that computer. Now, you don't want web requests to go to these guys because, well, we hope there's no web server running there. So you want to limit traffic to go specifically to the computer it needs to go to. And then we'll start with that. Well, and I'm thinking as far as POP, I'd like to see Bob here. We're assuming Bob's working from home and he always has the same IP number, which is not a good assumption. But let's put in a specific rule here to let Bob check his mail. So that'll be POP 3. And we'll see how that goes, because once we get started with ACLs here, we'll need to do this too. So anybody on your internal network should be able to hit the web server, of course, and the internal one, they'll already have access to that anyway because there's no router. And everybody here should be able to hit the mail server using POP 3. So we'll start with that, and we'll see how it goes. There may be some other functionality we can add to this. But as I pointed out before, you're going to need a border router anyway. You might as well use it to do some packet filtering. Now in the real world, we'd have firewalls right in here. We'd be using our border router to do some basic packet filtering for us, to take some of the load off of our firewall. And if you really understand what your the whole concept of packet filtering on a router, what a firewall will do for you will be a whole lot easier to understand, because it's a whole lot similar concept. Basically, you're looking at packets and making decisions on whether they should go through or not. So I think we can have some fun with this particular network.